Hello, this is video 9.3 on circles. All right, so let's talk about circles. We are into conics, and we learned already the first conic, which was parabola. We have been doing those all year. We've done the vertical, and we've just recently learned how to graph in the attributes of a horizontal one. Now we're going to look at a circle as another type of conic. So basically you have a cone with a plane that cuts that cone, and it forms the shape of each conic. And we'll learn more about that a little bit later. So let's just know what a circle is. A circle is just a round thing. So our objectives for this section is we're going to write equations of a circle based on different information, and we're going to graph them. But first we need to know what is the definition. So a circle basically is round. It's a set of all points that are equal distance from a given point in a plane that we call the center. So if we look at a circle and look at the center right here, all right, so that's what we're saying. It's equal distance from any 2 points all the way around to this center. Okay, and this is the center, which is the middle. The radius is a segment from the center to any point on the circle, and it's going to be called R. It's going to be the same distance all the way. So if I pick a point over here, it's going to also equal R. No matter where on the circle, that is R. Now, we can use our distance formula, which we've already learned, to write the equation of a circle that's translated by h comma k units. Just like any other function that we've done, we've got translations of hk. So let's look at the general formulas, the key concepts of the circle. So this is going to be important. So the standard equation when the center is at the origin, okay, this one, the center is not at the origin, but when my center is at the origin, 0, 0, the equation is going to be x squared plus y squared equals r squared, and the square root of r, which is r, is our radius. When it's translated right-left, hk, the formula is x minus h squared plus y minus k squared equals r squared. And you notice they're both minuses, the h's and the k's. So the center now is going to be your hk, and your radius is still the square root of r squared, which is r. So, like in parabolas, we learned that this is what we call our standard form equation of a circle. When it's in standard form, we can use the standard form of the equation to write an equation for a circle given the center and the radius or the diameter, because remember the relationship between the diameter and the radius is half, or the diameter is twice the radius. So let's look at the first real world example. They're giving us a radius, they want us to write an equation of a circle. So Appliances Plus More, which is the name of a company, offers free delivery within 35 miles of the store. The Jacksonville store is located 100 miles north and 45 miles east, so it's going to go up 100 and to the right 45 of the corporate office. Writing equations represents the delivery boundary of the Jacksonville store if the origin of the coordinate system is a corporate office. So, since the corporate office is at the origin 0, 0, that's all we really need to know. We know that Jacksonville Center is located at 45, 100, so that's going to be the center. So it went to the, it went to the left 45 and down 100, or actually went to the right 45 and up 100, right, from the origin. So the boundary of delivery region circle is centered at 45, 100, and it delivers within 35 miles of the store, which would be a radius. So if we look at and think about the picture and the drawing, we have here, our corporate office is here. Jacksonville is over here at 45, if we just call this 45, 100. All right, and it delivers within 35 miles, so that's going to be a radius of 35. So here, and then 70, 80. Right, and then about here and up here somewhere is our it makes a circle, right? The radius all the way around. So drawing these pictures can kind of help you get an idea of what's going on on your circle. Okay, so they want us to write the equation. So we know HK is 45, 100. And I don't know just what happened. Take that off. Okay, so there's my HK. And I just need my R, and they said what? It delivers within 35 miles, so R is 35. So now I can write my equation. X minus 45 square plus Y minus K, 100 square, equals 35 square, which is 1225. Oops. There's my equation. Circles are really simple. You just got to know you have HK, your center, and your radius R. All right, so let's look at example 2. This is write an equation from a graph. So this time, they give us actually the graph. Okay, so let's look at the graph here. So we know that this is our center. So we know H comma K is going to be what? -3, 1. That's our center. And they give us an X comma Y coordinate of 2, -1. Okay, it's that point right here. So we need to find the distance from here to here. We can either use the distance formula, or I know my equation is going to be X minus H square plus Y minus K square equals R square. All I need left, I've got an H and a K, I need an R. So kind of like using slope-intercept formula or point slope form, we can substitute what we have. We have enough to fill in the X, H, Y, and K, and then solve for R using basic algebra. So X is 2 minus H, so it's +3 square, plus Y is -1, minus K is -1 squared equals R squared. So I'm going to get 25 plus 4 equals R squared. So R squared equals 29. Now, remember, that's all I need. So my equation is X plus 3, because it's minus H, plus Y minus K squared equals R squared. I don't even need to do the square root because it's R squared. And there's my equation. All right, so that was simple. So now let's look at one where they give us points, and we're going to use the distance formula and the midpoint formula to find the equation. So they give us the endpoints of the diameter. So this is the diameter of a particular circle. So again, I'm visual, so I'm going to 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I'm going to plot those. 7, 6, -1, -8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so this is the diameter. I need, my center is somewhere in between here, correct? And then my circle just goes around. So I know the center is not at the origin, so I'm going to use X minus H squared plus Y minus K squared equals R squared. So I need to find the distance between here and here, and then I need to find this midpoint. So, because I need an H comma K, and I need an R in order to use my formula. So I was given the 2 points, so I can use the midpoint formula, and I get 7 minus 1 divided by 2, comma 6 minus 8 divided by 2, and I get this equals to 3, comma -1. That is my HK. There's my center. Now, so I have 3, comma -1. Now I need an R, so I'm going to use the distance formula between the given coordinates. So I'm going to take the square root of 7 plus 1 square plus 6 plus 8 square. And this is example 3, by the way, if you want to follow along in the book. And the coordinates given were 7, comma 6 and -1, comma -8. So those are those coordinates. So doing the math, I get, so this is going to be the distance. So the distance from here to here is the square root of 112. Now that's the diameter, and I need what? I need half of that. Okay. Oops, I did some bad math. This is square root of, so the radius, find the radius is this, the square root of 65. They actually used the point 3, -1, and 6/8. So, because we only want this. We don't want to deal with having to put in the calculator around and then divide by 2. We have to divide this by 2 because remember it's the distance. So we use this coordinate, 3, -1, and either this one or this one, we get it's the square root of 65 is r. And r square is going to be 65. So square root of 65. So now my equation is going to be x minus 3 square plus y plus 1 square equals 65. And you see, there's your equation. All right, let's do one more practice problem. Now, they're going to give us an equation that is not in standard form. Oh, actually, they give us in standard form, and they want us to find the radius and the center, and then they want us to graph it. So here's our equation. It's in standard form. So what is HK? HK is going to be 0, 0. There's my center, correct? And then what is my radius? So I look at, so remember it's equal to r squared. So to find r, I take the square root of 100, which is 10. So now I can go plot this 0, 0, which is my center, and then I just go 10 units, 10 to the right, 10 to the left, 10 up, and 10 down. And then guess what? I plot those points because I know the radius, and then I just make a circle. Obviously, mine's not going to be very pretty. I'm not good at drawing with this, but that's close enough. Right? Now here they use a table you can or cannot use. If you have the radius, you can just plot those points, that many units from the center, and you've got your graph. All right, now on example 5, let's move on to example 5. They're going to give us an equation that's not in standard form, and we want us to give the center and the radius, so we have to put it in standard form. So in order to do this, we must complete the square, just like we did with parabolas way back when, to put it in vertex form so it would make it easier to graph. So the first thing we want to do is we want to put all the x's together and all the y's together. And we're going to move our constant using algebra to the right side of the equation. So now we take b, 8 divided by 2 is 4 squared is 16. So that's what we're adding to this group. Here, 12 divided by 2 is 6, and squared is 36. So don't forget, it's b over 2 squared. We added 36. So what we add to the left side, we must also add to the right. So since we added a 16 and 36, we must also add that to the right. Now we combine that and we get 64. Here, now that we've completed the square, we can factor it. It becomes x minus 4 squared plus y plus 6 squared. So now it's in standard form, so my HK, or my center, is 4, -6. My radius is the square root of 64, which is 8. So now I can go graph my center. I'm going to graph 4, -6. And then I'm just going to go to the left 8 units. So 2, 4, 6, 8. And then I'm going to go to the right 8 units. And I'm going to go up 8 units and down 8 units. And then I'm going to connect my dots. And that's how you graph a circle. It's pretty simple, pretty basic. All right, do the homework problems, the practice problems, and we will see you in class.